percentage of the code that's written by developers inside of your environment and under the remit of your specific organization is maybe 10%, maybe 15% of what it is that you actually ship. Whether you're in cloud or whether you're producing a mobile device or whether you're like all of these, it's a conglomerate of third-party services, third-party software, could be licensed software through a negotiated license, could be open source software. The vast majority is probably open source at this point, which is super interesting because they don't even know that you're using it. So they don't know that they're part of your supply chain.
Hi, you're listening to The Secure Developer. It's part of the DevSecOn community, a platform for developers, operators, and security people to share their views and practices on DevSecOps, Dev and Sec collaboration, cloud security, and more. Check out devsecon.com to join the community and find other great resources. This podcast is sponsored by Snyk. Snyk's developer security platform helps developers build secure applications without slowing down, fixing vulnerabilities in code, open source, containers, and infrastructure as code. To learn more, visit snyk.io/TSD. That's snyk.io/TSD.
Hello, everyone. Thanks for tuning back in. Today on the show, we have Adrian Ludwig coming back on the show. He was on as Chief Security Officer of Atlassian, and now he's Chief Trust Officer with more responsibilities. Adrian has a very impressive security background. You can hear more about his story building the mobile security models back in Android, and also a little bit of his marketing career or sort of stint at Adobe in the middle. And so he has a really good lens and very great definitions and explanations about complicated problems. So today we're going to pick his brain around supply chain security, which is a topic that has its own complexities on it. Adrian, thanks for coming back on the show with this time, I guess, as a Chief Trust Officer at Atlassian. You were a CISO last time. So
yeah,
things are evolving.
They always are. Thanks, Guy. Happy to be here.
This episode, we're going to dig into supply chain security, and you're sort of leaning into this as well. You have different lenses on it. So I'm looking forward to kind of understanding a little bit, what's in your head, how you see the space and some practicalities. But for start, can you describe a little bit about how would you describe software supply chain security? What does that entail in the first place? Small question.
Yeah. I mean, it's a multi-armed octopus, or I'm not sure what the right metaphor here is, but the reality, I think, for most, actually probably for everywhere at this point, is that the vast majority of the software that you actually ship comes from somewhere else, right? The percentage of the code that's written by developers inside of your environment and under the remit of your specific organization is maybe 10%, maybe 15% of what it is that you actually ship. Whether you're in cloud or whether you're producing a mobile device or whether you're like all of these, it's a conglomerate of third-party services, third-party software, could be licensed software through a negotiated license, could be open source software. The vast majority is probably open source at this point, which is super interesting because they don't even know that you're using it. So they don't know that they're part of your supply chain.
They being the maintainers of the open source.
The maintainer of an open source project has no idea who it is that's using it. And that's one of the things that we've been trying to tackle in thinking about open source security is how do you even connect the dots of who to notify if you have a vulnerability and those kinds of things. So I think at this point, the biggest things for us are the well-defined elements of our supply chain are ones where we have an explicit license agreement, mutual understanding that a piece of technology is going to be used in our environment. And then the area that we have the greatest exposure in supply chain is open source software, where we know we're using it. We have an obligation to maintain it and make sure that it's being kept up to date in our environment, keep an eye on it, test it, et cetera. But the maintainers probably have no idea that we're using it.
Yeah, interesting. And I guess, how do you think, like within software supply chain security, sort of a mouthful, oftentimes there's at least one split is between kind of the components themselves that you're using versus maybe the journey that they make on it. I mean, how do you see them as the same? Do you see them as different? How do you think about those two?
Yeah, I mean, it gets complicated really fast. In an ideal world, each of the components that we'd be using, we would have a sort of singleton that we're able to manage in a well-defined way inside of our environment. So the journey would be a well-defined journey as well. In practice, in any organization, our scale, and any organization probably bigger than 2 pizza teams, they're going to be multiple instances. They're going to have migrated in at different times. They're going to have dependency chains that are different. They may or may not be imported as an object. They may be imported as source code and then been forked at some point. So that journey and understanding what that journey is definitely an area of complexity. One of the things that I'm very intrigued by is trying to see if we can reverse engineer those journeys and then make them simpler so that we can move to a world where we're just managing the objects. People talk a lot about SBOM, and the reality is SBOM describes just the objects. It doesn't begin to incorporate what those journeys are. And so we're a long way off as an industry from, really beginning to understand the complexity of the situation.
And if you had to kind of choose between the two, one being which components you're using and whether the maintainers know you're using them and whether they're secure, and the other is how the components are being consumed, which the security flaws in each of those, which one kind of keeps you up more? Which one is more concerning?
I mean, I think it's probably going to change over time. I think at this point, just knowing what the Lego bricks are that you're using is sufficiently challenging that getting to a point where you can manage it at that level would be really helpful. And then I think the next phase is going to be dealing with how they're being ingested, how they're being manipulated, how they're being managed. Now it's just inventory. Yeah,
and I think I agree with that. Like, I think it's like just fundamentally, it assumes securing the journey assumes you sort of know whose journey are you even tracking. So we talked about the open source components. Maybe there's commercial software that you're consuming. Maybe that's a little bit. What about the actual build system? So that's oftentimes also touted in supply chain security. Is that number 3 on the list? Like, where would you rank securing your own build systems from being tampered?
Great question. So I think I would put it as number 2. What you're intending to put into your production environment is sort of step number 1. And then step number 2 is, well, maybe the thing that I'm intending to put into my environment isn't exactly what I'm putting into my environment, right? Which is your development environment, your tool chain. Is there a compromise there? Is there somebody who's doing something malicious in that in that environment? Obviously, that's a priority, but I think it's less of a priority than sort of the unwitting accidental vulnerability that can be introduced by just not knowing what it is that you're actually shipping. Mm-hmm. After that, I think is where you begin to get into smaller and smaller exposure through commercial products, for example, or third-party services that have been integrated. So that's sort of the 1, 2, 3 that I would stack rank it.
Yeah, makes sense. For within the title of supply chain security, for the products that we use internally, what would you sort of say are like the top practices that you need to adopt to do this well, to secure them well?
I think a lot of times there's a discussion about, I need to see the SBOM. I need to understand what's inside of your environment. I have a security review that I need you to complete as a vendor. Show me all the details of how it is that you implemented your thing. And there's a lot of focus on the actual third party. What I think I have found is that there's less focus on how that integration is going to work. And in particular, how isolated is it going to be? Like, if I assume that vendor has been compromised, or if that component has been compromised, does that necessarily mean that my entire environment collapses? And I think the best security organizations are likely to be ones that are thinking about each of these components and then thinking about how those components are integrated into their environment, whether it be an actual software component or whether it be a third-party SaaS service or whatever, and defining the boundaries between them and the expectation, and then monitoring those boundaries, right? So that, I think, is kind of the holy grail for a well-federated internal environment, is one where you're using lots of services that don't have systemic risk across them, and they're isolated from one another, so that if your email provider gets compromised, it doesn't take down your messaging provider, and it doesn't take down. And that, I think, is where you ultimately want to end up, right?
In this context, you're sort of leveling up the supply chain security definition well beyond sort of open source components. And you're saying, just in general, is in your sort of software factory that you're building and you're deploying, as you deploy, say, a microservice to the cloud or a system to the cloud, or maybe it's not the cloud, but doesn't matter for intents purposes.
It's true for a component as well, right? Like, you should have a well-defined understanding of what it is that's flowing into that component if you can. I mean, it's tricky. Like, I have the naive simplicity of like a high-level architect as opposed to somebody who's actually wiring these things together and realizes that you have no idea. But yeah, if you have a component and it's operating only within a subset of microservices, then you can actually enumerate what it is that could be exposed to that component. And then you can reason about what level of risk is associated with that component being compromised. And we don't tend to think that way. I think as humans, we tend to think it's just a soup. But if you architect it to separate these pieces out, you're not actually accepting a lot more risk by having a more complex supply chain because you've isolated across the different components.
And in practical terms on it, like which processes and which tools would you need to successfully do that?
So for us, one thing that we do in our production environment is microservices are considered to be a security boundary. So there's authentication between them. There is encryption between them. The set of interactions that is expected between those microservices have policy applied to them. In practice, it's difficult, but in theory, you can very quickly say, this component was compromised. Maybe it was compromised because somebody found out that there's a vulnerability. Maybe it was compromised because somebody found out that the component had actually been manipulated, like we've seen that in NPM and a few other places, not to name them. It could be happening anywhere, I promise.
Yeah, in every package.
That's a place that we've seen it. And then you can say, okay, what could that have possibly accessed? And you actually can reason about it, which is very different from a classic monolithic environment where you just have no idea because it could have accessed everything. And there's no way to constrain that. And so we see that variation when we look at, for example, on-premise products versus cloud products. Cloud gives you the ability to have that architectural isolation between microservices, and on-prem doesn't. And so the same vulnerability in the two different environments has a very different impact.
Yeah, I think that makes a lot of sense. If I echo this back, though, you're saying in practical terms, it is easier to apply this philosophy at the resolution of say, a microservice. And in those cases, there's something very practical you're doing here, which is you enforce those as a security boundary. In concept, though, as a community, as an industry, if someone builds further tools, and I know there's a bunch of startups trying to do things in this world, you can actually further reduce the security boundary to a component level. But at the moment, if you're sort of going to implement something, which you are, like in your own environment, microservices is a reasonable place to start.
Yeah. Especially if you have something if you have an application that can be broken into 100 or 200 microservices, then you get a huge amount of isolation by having done that breakdown.
Yeah. And I love that that's like fundamentally, that's just sort of a good security practice, but it's also a good reminder that while you may not have full visibility, full understanding of the components you consume or their journey or whatever it is, what you can do is you can just sort of put them in a package that constrains what they can do and monitor that package.
And it's relatively
small enough to be useful.
Like the interaction from one microservice to the other, it's like templatized. The set of API calls that can be made, it's pretty narrow. The set of data that can go back and forth is pretty narrow. So it's not hard to imagine a world in which you can do monitoring of that with a very high degree of precision to make sure that there's nothing fishy going on from one to the other.
Yeah. And do you, not to name specific names, but do you feel like the tooling in the ecosystem today is able to give you that more out of the box, or do you need to invest a fair bit at figuring out those templates and enforcing them? I mean, how much can you purchase your way in tooling to this versus things you have to build?
I actually don't know. I suspect if I go talk to vendors, there are probably a dozen vendors that would tell me they could do it right out of the box. The environment that we're in, we've done a lot of it sort of in-house already. And so we haven't really looked for it. Now, my suspicion is that the types of automated things that are out there probably are a lot better than what we have. That's sort of what I would expect, right? If you have a team of 50 engineers that are working on something specifically to bring it to market, and this is the classic trade-off, right? Is do I want to invest in something that's bespoke to my environment, or do I want to sort of go along with a larger investment that's controlled by a variety of different customers that have input into their solution? So right now what we have is mostly bespoke.
And if you build it, yourself, then you can structure it in that fashion because you build it on like a somewhat consistent platform that applies those templates. This approach, or what we talked about up until now, indeed focuses on internal applications. You're running them, you're hosting them, and so you can apply those perimeters. Maybe let's shift gears to ones that you deliver Atlassian. You also ship software that others really run with their system. I guess with the new supply chain security adages, what has changed in the practices you need to have to deliver software to customers?
Expectations for what is acceptable in terms of providing visibility into what's in your supply chain and how quickly you respond to issues that arise in your supply chain have changed pretty dramatically in the last 2 years. Within 24, maybe 48 hours of a significant open source vulnerability being announced, we have customers banging on our door asking us, have you scanned your entire environment? Have you fixed every single instance of it? It's like, hang on. Yes, fortunately, we're usually able to answer. But that rate at which people demand answers has radically changed. And so I think you need to be at this point capable of scanning your whole environment and being able to answer those kinds of questions. That's just sort of where the direction of the industry is going. I think the other element is, even if something is not vulnerable, if it exists in your environment, there's an increasing expectation that it will have been fixed. 3 or 4 or 5 years ago, it was easy to say, yes, that vulnerability exists. It's in an area of code that we do not invoke. Therefore, it's not really a vulnerability. It's just a bug. It's basically in dead code. At this point, we have lots of customers that are saying, that's not good enough. I hate to say this, but like, we fundamentally don't trust your analysis. And we think that no human in the world is possibly smart enough to make that conclusion. Go fix it. It's like, well, hang on. That is the guidance that we've always received from NIST and from the security, like prioritization of things that are actually exposed is, we know that that's the right way to go, but there's just such a deep rooted lack of confidence. And really what it is it's like overconfidence in the exploitation community that makes it really difficult to reason about those things. So I think we're moving towards a model where if anybody finds a vulnerability in any library, then that library has to be up to date. That ends up creating a lot of back pressure on making sure that you're always up to date on everything. Because if you skip 1, 2, 3, 4, 5 releases because there's no vulnerability in those updates, then you have to, in the 6th release, a vulnerability is there, whether you're exposed or not, you need to fix it. You need to do it very, very quickly. And so you need to have the training within your team and your organization to be able to do that. And you can't have tech debt of 5 releases or 6 releases.
That's super interesting. So just to sort of establish the baseline, you're saying you kind of need to get your act together about dependency management and tracking what you are using in the first place before we ever we haven't even touched the sort of delivered SBOM to a customer. But you need to know because customers are going to demand it from you a lot faster. And then second, and it sounds like you're sort of saying it like you're partly complaining about this. You're sort of saying it's beyond logic. It's just sort of this general fear. Maybe, I mean, if I dare say, it's also like a little bit of mistrust in how some like vendors in the past have sort of tried to brush vulnerabilities that were real under the carpet because it was easier than to actually sort of face them. Now there's a much more sort of substantial demand to actually upgrade the libraries, regardless of whether they are exploitable or not.
Yeah, which it's super interesting. Like I go back 30 years in the software space. I would argue early on, there was a lot of work on like prioritizing and making sure that the security organization was never sending something that wasn't like exploitable. And Microsoft was right at the forefront of saying, basically, asking our security team to prove that something is exploitable is a waste of time. We're just going to assume that it's exploitable. But I think that hasn't really sunk into the relationship between security teams and engineering teams. And so there's still this constant, oh, how would you prioritize this? Oh, how would you demonstrate that it's real? That kind of negotiation. But what we're seeing now is that the customers basically are not willing to participate in that. They're just going to say, we assume everything is exploitable and you have to
fix this. Yeah. Let's talk about the SBOM piece, because the other aspect of this is today you're sort of expected to proactively provide that list of components to a customer. No? How do you handle that?
Yeah. So SBOM is super interesting to me. I think there's a couple different ways to think about it. One is that it produces a sense of transparency. And that in general, I think a sense of transparency leads to better alignment of incentives by the organization that's creating a piece of software. So I think that's like a hugely valuable thing to think about SBOMs is like, as soon as I have to describe what's inside a piece of software that I'm making, then I'm going to be very, very careful about what's in that piece of software. That's one like optimistic SBOM is good and it will drive the effects that we want. The other more realistic, but super negative way to think about SBOMs is it shifts the responsibility from the company that's producing a piece of software to the consumer of a piece of software to know what's in there and to make demands about it. And that, unfortunately, is, I think, the overwhelming direction that SBOM is going, right? The consumers of SBOM, whether they be a large financial institution or whether they be a healthcare organization or whether they be a government, they are the ones that are very excited about SBOM. And I think the idea of managing software development at the level of dependency management as an external party is horrifying. So hopefully the sort of the one that I have on the right, in this instance, I'll say the right side is the correct side. That one hopefully will end up becoming more significant and companies will do the right thing in order to avoid having lots and lots of painful discussions with customers. But we'll see whether that incentive structure sets up. But right now it's like, okay, produce an SBOM, and then it's going to get ingested by some other automated tool set. And then the security team at your largest customer is going to ask a bunch of questions. And That, I think, is a recipe for a mess.
Yeah, sort of another way, tell me if you agree with this, but another way to think about the positive lens of it is like the food ingredients, piece of food that you buy in the supermarket. If it's poisonous, then it's still the responsibility of the provider, whoever made that food, to not send it to you, that they would be negligent or like cross some other law if they did that. But if you're allergic to nuts and the thing has nuts in it, then it's okay to sort of roll that responsibility as long as it's properly noted on the consumer.
The metaphor, I think, is a good one. The question is whether the consumers of software from a SBOM standpoint, so which basically comes down to from a security dependency management standpoint, are sufficiently different that what is healthy for one is poisonous for another. And I don't know that I buy that analogy, because that analogy is absolutely the case if the consumers are different, right? Yeah. But I just don't think we are. I think we're all pretty much the same.
I think that's a really fair point. And I guess that's the question we sort of need to learn to find out. This kind of slips us indeed into that sort of third bucket that I mentioned, which is as a consumer of software. So I guess with you at that seat now, you're also consuming software at Atlassian. Some of those vendors started giving you SBOMs. What do you do with them?
Not a lot. Certainly they exist. We could look at them, but, and this is also, I think, where the market effects are super interesting, right? Any product that we're using at scale is one that's going to be validated by lots of other companies. So do I want to dedicate a bunch of my security organization's time and effort to making sure that everything is absolutely correct inside the SBOM of every one of our vendors? No. I don't think that is actually a sensible allocation of resources within our organization. So do we have them? Yes. Do we look at them? Sure. Are we investing a ton of resources in optimizing our analysis of them? No.
No, I think that's a good answer. And I will say that there hasn't really been anyone that I've spoken to yet that has a fully firm understanding of what they will do with them. Maybe with the exception of, hey, if there's another Log4Shell, then at least I would know to go and query that list in whatever way it's stored to see if it's in there.
Yeah. You could do something with them. I mean, I think having the data is useful. It's hard data to understand and use in a reliable way.
And what are you going to do? You're going to come back to sort of people, to a vendor and say, yeah, you have this medium vulnerability. I guess that's precisely the behavior that you were sort of critiquing a moment ago. It's like you'll come back and say, oh no, you have this medium vulnerability over here. You need to fix it. It's like, well, is that really what you want the vendor even to be spending their time on versus building functionality that you need?
You probably don't have enough context to be able to analyze that.
Just as a bit of a fun anecdote, is one interesting use case for the SBOMs is cyber insurance. To an extent, you can use the profiles of SBOMs, especially as they evolve over time, to understand whether something is basically to deduce security practices of the organization, which I thought to be an interesting, but I don't think you're going to do that as a vendor, but maybe your cyber insurance provider will start asking for those SBOMs to assess the price of your premium.
Yeah, I don't think we've figured out the magic bullet yet for understanding the level of risk that exists inside of an organization, but maybe the insurers will figure that out.
You've already had a lot of healthy practices. Like when you look at from a change perspective, you look maybe a couple of years ago versus now, again, with that lens of software supply chain security, how have your practices changed? Like which priorities have kind of gone up that maybe a couple of years ago you would have kept a bit lower?
So definitely investment in dependency management, regardless of whether there's known vulnerability, has gone up. Investment in simplification of dependencies has gone up. I have a dream, and that dream is one where as soon as a dependency is out of date, we immediately apply a patch that updates that dependency and push it. And there's sufficient robust A/B testing and validation within our dev pipeline that can happen. And if something breaks, it turns out engineers are really, really good at fixing reliability issues, and they are very proactive about it. And so shifting the entire discussion of dependency management and supply chain management into one where we're willing to create outages because we have sufficient confidence in our A/B testing and our automated rollout system that it happens infrequently, but this way we can just solve dependency management. All the toil related to that can go away. That's the dream for me, as we get to a point where all the libraries are up to date all the time. All the components are updated all the time.
There's an interesting kind of counterpoint actually with the malicious components right now, and like it still promotes the same automation on it, but it's just about precisely how quickly do you automate. And at Snyk, we actually ended up, our automated upgrade pull requests actually open up some delay. Snyk actually tries to address this malicious component problem by delaying the proposed upgrade, when you're using it to upgrade your dependencies for new versions, and only opening it up, I think it's like 30 days after or something like that, so that you are less susceptible to a malicious component. If that came along, the ecosystem would flush it out. But if there is a vulnerability in the component, then the fix will be opened right away, because you do want to adopt those fixes as quickly as you can before the exploits happen. A new version will come out fixing a vulnerability that has just been disclosed. And so for those fixes, you want to get them right away. And actually, it reminds me that the sneak functionality has an exception, an asterisk with unless there is a vulnerability in it. So if there's a vulnerability in it, it opens right away as a security fix. But if there isn't a vulnerability in it, then it opens up the upgrade.
I mean, what we've seen in terms of timeline from disclosure to exploitation is hours, a day or two. Yep. It's not days and it's not weeks. So, I mean, I think differentiating like known vulnerability, prioritize that versus no known vulnerability, then slow it down. And that I can see that. That makes some sense.
Yeah. And that
also probably gives you some coverage on reducing the amount of churn that you need, like only update once a week, unless there's a known vulnerability or something like that. Probably if everybody's on a non-synchronized schedule for doing that, then you probably get pretty good. You reduce the likelihood of someone being able to successfully roll out at scale a modified version of a library.
So this is super useful in its practices around, if you're sort of leaning into supply chain security, what to prioritize and what to do next. Let's take a moment and look at the industry kind of outside of Atlassian. So you've been a member of the OpenSSF board for the last bunch of months. A lot of activities, a lot of work happening over there. Which projects or activities do you think are currently the most important, maybe the most worthy of tracking for someone who's not sort of living supply chain security?
Great question. I mean, it's sort of this interesting space where, because there's no charter for open source, and there's no like unifying organization, et cetera, all of the things are missing in varying degrees across different parts of the organization. So there are certainly some parts of the open source community where they have no notion of incident response. They have no ability to respond when a vulnerability gets identified. There are other parts where they have great incident response, but perhaps they have no training. So I think one thing that OpenSSF has done is tried to encapsulate like, what are all of the potential things? And then let's begin making progress against them in parallel, which is definitely a broad approach. And hopefully it can help in each of the different areas. The areas that I think have received the most attention are around flow of information and then prioritize review. So how do you know which areas with SBOM, for example, which things are relevant to you? How do you identify which libraries you have dependencies on? So I think that's a pretty important one, right? Just understanding the pieces of code that you're using, what those dependencies are and how they relate to one another. That's probably among the most important things that we're working on, is trying to get that in place.
When you think ahead, maybe a little bit less practical, a little bit more sort of further out to the future, which projects do you think are kind of the most aspirational, right? The most promising? If this pulls off, if they pull this off, if we pull this off, that would really make a difference.
It's shocking to me that some of the basic exploitation mechanisms, buffer overflows, have been around for 50 years. Heck, I've been exploiting them for 30 years. And yet we continue to write core parts of our technology in these languages that have problems and using methods that are known to have problems. So I think longer term, transition away from known risky languages and methods to less risky Rust, I think, is really attractive in that regard. It's odd to me that we prioritize performance so high and at the same time have layer upon layer upon layer upon layer of abstraction that just destroy performance. I think that as a long-term bet is going to be really, really valuable. Getting clear security contract baked into the languages and tools that people are using.
Yeah, that is indeed. I think it's kind of you're indeed answering kind of my question about aspirational, because it's a bit hard to sort of figure out exactly how do you engage in these massive, critical, central projects and rewrite them in a different language. But there's an ambition there to do that as one of the tracks.
Yeah.
So Adrian, this has been sort of great, a great journey into supply chain security, your views on it and how you apply it in Atlassian, to sort of grow that ahead. Maybe my kind of regular open-ended question, that I have at the end of it, but maybe since we sort of focused on supply chain security so much here, sort of narrow into that world. If you had a limited budget and limited resources to tackle one problem in this world that's pretty big of software supply chain security, what would you tackle? And maybe if you have thoughts, which path would you take to tackling it?
As we've seen it so far, like we tend to think of ingestion of open source projects as just a win. And what we lose track of is that there's a long-term management cost associated with that. And so the more we can automate that management, the better. And in my world right now, the way that looks is getting to the point where having the most recent, most up-to-date version is the default. Whereas right now, the default is you have the version that you ingested like 10 years ago or 6 years ago or 5, depending on how old your organization is. At some point, somebody pulled in that version and it's just there hidden in your repos somewhere and you didn't know it was there until you run a security scanner and it's like, whoa, that's scary. And then you're like, how do I undo neglect of N years and get it to the point where it's up to date? So I think the default needs to be it's up to date.
Is that aligned with like the serverless ethos and sort of a platform as a service model in which you consume it and run and something swaps it, or you're envisioning a software version of it where even if you're hosting it in your own setup, it's sort of
I think it's going to depend on your specific environment, but it could be serverless, right? It could be that it's in the images and then you don't actually invoke anything directly. That could work. I think the reality is most places that I've interacted with are also ingesting a lot of things as source. So figuring out how to manage it as source is also probably important. But regardless, we have to flip the model so that the default is that it's up to date, as opposed to the default is that it's not up to date.
Oh, that's great. Now I'm curious about the second. So what's the second sort of ambition is?
Legitimate security boundaries between those components. So being able to have confidence that any exploitation is isolated and contained only within those areas. And so maybe that's base image and the base images are actually isolating them out. I don't know, in a serverless kind of model. Maybe it's something else, but that level of isolation would be amazing. So if you could both know that your components are up to date and that any compromise of them is contained within just that component, pretty good shape at that time.
Yeah. Indeed. This has been great. Adrian, thanks for coming on to the show again.
Happy to be here. Yeah, this was fun.
And thanks everybody for tuning in. And I hope you join us for the next one.
Thanks for listening to The Secure Developer. That's all we have time for today. To find additional episodes and full transcriptions, visit thesecuredeveloper.com. If you'd like to be a guest on the show or get involved in the community, find us on Twitter at @DevSecCon. Don't forget to leave us a review on iTunes if you enjoyed today's episode. Bye for now.